You think your serverless functions are secure, but a single line of code could be exposing your deepest secrets to the entire internet. Developers love environment variables. They are the standard way to store API keys, database credentials, and configuration settings in the cloud. But here's the problem. When things break, we debug. And often, we print those environment variables straight into our system logs. These logs aren't always private. Misconfigured permissions or a third-party monitoring tool breach can make them readable to attackers. Sometimes, developers accidentally commit an env file to a public repository. In seconds, bots scrape these keys. It happens every day. So, what can an attacker actually do with just one exposed API key? The answer is terrifyingly much. They start with initial access. They authenticate as your application. To your cloud provider, they are your application. If that key belongs to an admin role, they now own your infrastructure. They can spin up instances for crypto mining or delete your backups. Even with limited permissions, they can move laterally, from the function to the database to the customer records. Once inside the database, they exfiltrate user data, emails, passwords, payment info. This is how major data breaches begin. The cost isn't just technical recovery. It's regulatory fines, lawsuits, and a shattered reputation that takes years to rebuild. So how do we stop this? We need to fundamentally change how we handle secrets in serverless architectures. First, stop using plain environment variables for sensitive data. Use a managed secrets manager service instead. These services encrypt your secrets and only inject them into the application memory at the exact moment of runtime. Because they aren't standard environment variables, they don't accidentally get printed in your error logs. They stay invisible. Secrets managers also allow for automated rotation. You can change your database passwords every week without redeploying code. Second, implement strict identity and access management. Give your functions the absolute minimum permissions they need. If a function only reads from a database, it should not have permission to delete it. Limit the blast radius of any leak. Third, enable detailed audit logging. You need to know exactly when and where your secrets are being accessed. If a development API key is suddenly used from an unknown IP address in a foreign country, your system should scream. Security isn't about being perfect. It's about layers of defense. Secrets management, least privilege, and monitoring. Don't let a leaked environment variable be the end of your cloud journey. Secure your secrets today. Thanks for watching.